Okay, we'll go ahead and get started. I wanted to do a little quiz game, but I'm going to go over this notebook first and then we can get into that game. I just want to have as many people here as possible. So if people are running late, we'll have more people for that. So we'll talk about today a little bit about data integrity and then timeliness. And then we're going to go over, there's going to be a little bit of homework. We'll go over that. And then we're going to talk about the final project a little bit. And then look at for the final project, some data exploration, where to find data sets and such. And then we're going to do like a mini project walkthrough that's going to be like follow along. I've put the files in the shared folder for that. So yeah, that's for today. So I'll go over the data integrity and the timeliness right now, and then we'll do the Kahoot after that. Hopefully more people show up. So I think we've talked a little bit about, well, we've learned how to clean data and how to get proper data for analysis and visualizations. So like data integrity refers to the accuracy, consistency, and reliability of data throughout its full life cycle, from creation to storage, processing, and then whenever we're done with the data. So this is like being able to manage your data and making sure that we have accurate and consistent, complete data is obviously very important, because we talked, I think, in last class how all these companies, they have so much data, and data for companies is like gold. Like it is so valuable unless you don't know what to do with it. And obviously, if it's not good data, it's not accurate data, not complete data, it's not going to be too valuable for them. So for business intelligence and data analysis, like maintaining data integrity is so important. Again, we want that data to have value for companies. There's no reason to collect all this data if you won't be able to use it. High quality data allows us to derive insights and make good decisions that can help with the organization's success. And alternatively, low data integrity can lead to, bad decisions, poor reputation, just damage. So several factors that contribute to data integrity include accuracy. So the data should accurately represent the real world entities or events that they describe. Completeness should include all the necessary information with no gaps or missing values. And we've talked about data cleanup, how to deal with null values, empty values, missing values. Some of the ways is whether we fill them up with mean, median, the nearest neighbor, to make sure that we have complete data. And consistency, it should be coherent and uniform across different systems, databases, and time periods. Again, if we have our data in a SQL database and then we're importing it to Tableau, we're importing it to Python, we want to make sure that it stays consistent throughout that nothing wonky is happening there. Timeliness, we're also going to talk about that in a little in more depth, but like data should be up to date, reflecting the most recent and relevant information available. If we have old data, it may not be as valuable anymore. So for example, looking at the big tech companies, Google, Facebook, they collect a ton of our data, but they want it to be very recent data in order to be valuable, in order for them to make decisions and stay up on trends. And for example, we all know that Meta like tracks your Google searches and whatnot. So then they'll show you exactly what you've been searching. So that's kind of like the timeliness for the data, it being up to date, it's very recent. Validity data should adhere to predefined rules, standards, and formats that govern data quality. Talked about like formatting dates properly, making sure that dates are all, in the same same format. That we treat, if we have talked about like knowing what is the decided like date format, and looking at also time zones, whatnot. So like making sure that makes sense. Uniqueness, getting rid of duplicates. We've looked at that in our data cleaning notebooks, and how to get rid of duplicate entries and records, even if there's like one unique column, such as the customer ID, but everything else is exactly the same. That should not be included. Otherwise, it might lead to inaccuracies. So to ensure data integrity, organizations must implement a range of measures and best practices: data validation, cleansing, transformation, security, access control. Understanding data lineage and provenance can help track the source and history of data, which is crucial for maintaining integrity and troubleshooting issues. And so some examples on accuracy: a healthcare organization maintains a database of patient records. Recording vital signs, blood pressure, heart rate are inaccurate. This could lead to incorrect diagnosis and treatment plans. And obviously we want to make sure that when we record those vitals or information about this patient, it is recorded for the right patient and therefore accurate. Completeness, a glasses company analyzes sales data to optimize inventory management. If the data set is missing information on certain products or sales transactions, the analysis may not be accurately reflect the company's true inventory needs. For example, if we were to try to estimate next quarter sales, but we are missing 1 month's worth of data from this quarter, it might not be as, like, the data is not complete, so our trend analysis might not be as accurate. Same thing. We were looking at the sales data for the model cars last week, and we had 2023, 2003, 2004, and then we'll have like a few months of 2005. So if we were to, analyze what's going to happen in 2006, then since we had no idea what happened in 2005, it's going to be a little bit harder to do that, even though we do have a couple earlier years worth of data. Consistency. A multinational corporation has several databases for employee information managed by different departments. The formatting or naming conventions for employee IDs are inconsistent across databases. It may be difficult to accurately track and analyze employee performance. Like the column names, again, talking about like we have a database and then we're going to bring it into Python, or we're going to like display it in an application. Keeping those column names like consistent throughout is going to help everybody so much, because if in the database it's like customer ID and then you're going to bring it to Python and call it customer_ID, it's just going to lead to confusion and can cause inaccuracies and errors. So that's a good way to like keeping everything consistent. And then obviously this one has an employee IDs. For example, if they have certain formatting in a database, but then the formatting is changed in Python, it can just lead to confusion. So stay consistent with formatting and naming conventions. Timeliness. A financial institution relies on up-to-date credit scores to assess the creditworthiness of a loan applicants. If the institution uses outdated credit score data, it may approve loans for high-risk applicants or reject creditworthy ones, resulting in potential final losses. That's straightforward. We want recent and up-to-date data. And that's like we've looked at how to import data in our notebooks. One way is obviously uploading a local CSV file. Then we can connect direct to a SQL database. We can read directly from a URL. So connecting to a database that we know that is getting refreshed daily, weekly, however often the data should be updated, or connecting directly to a URL that we know that it's getting updated. It's going to be a better way to read the data than just having a local copy that you have to update yourself because it might not be up to date if you forget to update it. Getting it from like the source, like getting as close to the source as possible is usually the best, and one that is being updated properly. Validity, e-commerce platforms stores customer data, including email addresses. If the platform doesn't validate the email addresses, it may store invalid email addresses, leading to failed communication and potential loss of customers. And I think we talked about like with regular expressions, validating the email formatting, phone number. So that is very important that if you're ever building an application or you're building a form that is collecting data, that's like having the validation for your data when it needs to be certain format, such as an email or phone number, social security number. We like that. We want to do the validations to minimize inaccurate and not good data. Uniqueness, marketing agency analyzes customer data to create targeted advertising campaigns. The dataset contains duplicate customer records. The analysis may overestimate the size of the target audience, leading to an inefficient spending on advertising. Yeah, we don't want duplicates. It's never good. It's just gonna cause problems with the data. Any questions on the data integrity? This is probably maybe something that was discussed a little bit in Tableau or SQL, or maybe not, because depending on what kind of data sets you guys were using, if they were already all nice and good and didn't require any transformation or cleaning. And then timeliness, combining, updating, refreshing data. So automating data updates, like I said, something that gets refreshed consistently. Implementing automated process to fetch, process, and store new data at regular intervals. Could involve setting up scripts or using ETL tools to collect data from various sources, an object database or data warehouse, utilizing APIs, webhooks, and other data streaming technologies to collect real-time data. The script that I showed in the very first class, my personal script, like, for example, I have the data that I'm kind of modifying, like that was the calendar scripting that kind of like filters out the calendar events. So the original calendar gets updated every time the app is opened. And then my script, I think I set it original to update every 3 hours. And then I was like, oh, like sometimes I do look at it a little more often. So then I set it to like every hour it gets updated. So like that's one way to, you get the more updated data. And we talked about Alteryx at one point, I think in a very first class, about some other like business intelligence tools. That was it's like no code workflows where you can pull data and like transform it and then push it. So that one you can set up intervals to run your processes and transformation data. So using different kinds of tools and scripting, whatnot, to automate your data updates. We love automation because it gives us more time to do things that require a little more brain power. Establish data update policies. Define policies specifying the frequency and the methods for data updates. These policies should consider the nature of the data, the volatility of the information, and needs of the organization, and ensuring that all team members adhere to these policies. If you're, for example, creating a dashboard, you're publishing it online, it's like good to include a tiny little disclaimer at the bottom, like how often that data is being updated or when was the last time that it was updated. Whether it was like, you could have, like last updated noon today, next update noon tomorrow, if it's just once a day, or then it's last updated at noon today, and then every hour it gets refreshed. Monitoring data sources, regularly monitor data sources to ensure they're functioning properly and providing accurate, up-to-date information. Address issues with the data sources promptly to minimize disruptions to data timeliness. That was like one of the notebooks, I think last week, the iris data set. I think something had changed there that I had to kind of like go modify my code to account for the change. So it's good to monitor the data sources, and because especially if it's a data source that you have no control over it, let's just say you work in the analysis department and you get this data from the marketing department, but you don't have access to their database, and they end up changing the name of a column or deleting a column that is being used. It's just going to break the whole process. So, and if you don't look at the dashboard that is using the data, and you have no idea that it's broken. So monitoring, or then having some kind of triggers that is gonna tell you when things break. Using timestamps and versioning, record timestamps in the data to track when it was last updated or modified. This allows users to easily identify the age of the data and determine if it's still relevant. Kind of like what I was saying, including that little disclaimer or timestamp in your dashboard to tell the user when was this last updated and when it will be updated next time. A very great example of that is, since I'm in Florida, I look at the hurricane during hurricane season. We look at the hurricane updates, and that one I think updates every 3 hours. They show their, forecast of where the hurricane is going to go. So if let's just say they forgot to update it, and then it's going to be like yesterday's, it might not be very relevant anymore if the hurricane is nearby. And then version control, talked about Git, GitHub, tracking changes, making sure that the most recent version of the data is being used. Setting up data quality checks and alerts. Implementing data quality checks to monitor the timeliness of the data. Should include comparing the age of the data to predefined thresholds or comparing the data to other sources for discrepancies. Setting up alerts to notify the responsible parties when data timeliness issues are detected, allowing for prompt action to address the problem. So yeah, making sure that wherever you're using the data, it's properly working, nothing's breaking, just being aware what's going on with your results, what you're doing. Let's see, about 23. Let's do, first of all, anybody have any questions on this? Okay. There goes my dog. So I would like to do a little Kahoot. Anybody not familiar what Kahoot is? It's like a quiz platform.
I know of it, but I don't think I've ever used it.
Okay, so how it works is here I think you can do it from your laptop, but I always like to do it with your phone. So you'll just go to like kahoot.it, and then you're going to put in the pin. And what's going to happen, it's going to show a question on the screen, and then it's going to show like 3 answers, and then you just have to choose with the correct answer. And then we'll pause like after each questions, like if a little bit of clarification or if you guys have questions. Or we can also go all the answers like over at the end. But yeah, it's like very straightforward. I don't know if I did a good job explaining that. But yeah, it's just like a little trivia platform basically. So yeah, go to the kahoot.it, or I think you can scan this QR code as well, put in the game pin, then put your name to play the game. And the faster you are, the more points you're going to get. And then I don't remember if you lose points for wrong answers. Maybe not. And then there's a couple questions that have like double points. Carmen and Roni, are you guys able to join the game?
I can. I just don't have the second monitor set up just yet, but I can. I've been through the class before, and so I'm just listening
Okay.
to try to get it into our curriculum, at school
Okay.
wise. So that's really my motivation.
You can, I think if you open it, like it'll show the questions where you're answering, so you don't necessarily need to look at both screens. But
Okay.
yeah, if you want to test your Python knowledge,
Gotcha.
feel free to play.
It's toggling between the two apps on the phone without another device. That's the problem.
Oh, you're listening in. Okay,
Yeah,
I see.
Yeah. If I can get the other device set up in time, I'll get up there.
Okay. Yeah, you can also join like during the game.
Okay.
The pin stays like on the screen.
Yep, we use Kahoot in school.
Yeah, it's fun. Okay, I don't know. Yeah, we'll just, I don't know if anyone else is joining, so we'll just go ahead and get started with this. So yeah, the question is gonna pop up. It'll show the question first, so you have like a little bit of time to read it. Then it's gonna keep showing the question, and then it's gonna give you like 4 different answers, and you just need to select the right one. Any more questions? Cool. And if you don't know, don't stress. This is just a little fun to review what we've learned. We have 20 questions, so this will take about like maybe 15, 20 minutes. Okay. Starting the first one. Nice. Everybody got that one right. We talked about floats, the type of data type in Python, which is just a decimal. Next question. Oh, let me see the points. Nice. I think my camera is having a field day right now. Maybe I'll just turn it off for a second because it's glitching. Next question. Okay, so in Python 3, we do get the correct, like the real answer. There's no rounding involved whatsoever. So when we divide 1 by 2, we're going to get 0.5. Okay, so if you remember in most programming, if not pretty sure all programming languages, indexing starts at 0. So H is going to be our index 0 and E is going to be our index 1. So when we go and get the index 1 from S, it's going to be E. Any questions on that? It takes a little bit to get accustomed to the indexing. Okay, and then with the slicing, so same thing, index 2, so 0, 1, and 2. M is going to be at index 2, and then the colon means like we're slicing from start to beginning, or like start and end. But if we don't put anything at the after the colon, that just means we're going to get rest of it. And if we had put something in here, the first one is inclusive, and then the end is exclusive. Nice. Wait, no. Oops. Yeah, this is one that I get wrong, or like I always get confused about. With sets, it's add, and then with lists, it's append, and then I think with dictionaries is also append. So, but both of those get used in Python, and it's not an end of the world if you don't remember, because it's easy to look up, or then you can just run the program and it's going to complain and say that method does not exist, and then you can just try the other one. So with the set, if you remember, sets do not include duplicate values. So when we pass in a list, an array that is 1, 1, 2, 3, and we create a set out of it, it's going to get rid of the duplicates. So we're only going to have one in there. And then this one, the squiggly brackets, that's what is a set in Python, and the brackets is a list. So red one, that's a list, and then green one is a set. string. So we learned about collections in the very first class. We have tuples, lists, dictionaries, that like having multiple items, meaning, you can put multiple objects, you can put multiple strings, and then dictionary, we have the key value pairs. This can be multiple integers, multiple strings, multiple items. And then tuple is similar to a list, but it's just, you cannot, once you assign it, you cannot change it. And then string is that's just that one variable. You cannot assign multiple values to one string variable. Okay, yeah. DEF, so define. They are called functions, so that is a very tricky one. Define, and whatever you want to name it. DEF, that is how you start a function. Nice. Everybody got that one correct. LEN, length. That's how you get length of a list. I think we get length of everything with that. If you ever do end up learning Java, they use different, I think size is used for arrays, length is used for strings. That one gets confusing there. Python is straightforward, just with LEN. Try except. We're gonna do try, and then you do colon, then you put in whatever code you want to try, and then we're gonna do except, and that's how it's going to catch it if an error occurs. Okay, so mutable means that it can be changed. So list, when we define a list, it is mutable, which means you can change out the elements of a list. So we're basically changing it. All rest of these, once you assign something to s equals hello, you can't change the hello. You can overwrite where s points to, but you cannot ultimately change, modify what it was previously. So list is the only one from these options that can be modified. Yeah, so in a list, we're going to append it. In a set, it was add. So yeah, list we append. Okay, so if you remember, I think we went this over in the very first class. When we have two, so 2 stars, this is an exponent in Python without using like any external libraries. This is how you can do an exponent. So you do 2 stars. And if you just did 1 star, then that's a multiplication. And that is pandas. So pandas, especially in a tabular format. So we've been looking at data frames a lot, helps us play around and wrangle the data. Matplotlib is for visualization, PLT. PD, so when we've assigned PD as the alias to pandas, which we've been saying import pandas as PD. So PD.read as CSV is how we're going to read it. There is not open file, but open is when you read a file without pandas in Python, just doing like open, which I think we've seen like a very quick example somewhere, but we haven't really looked at that. Yep, for loops, for number in numbers, for n, for I in an array, for loops. SkyPy. So last week we were doing visualizations with Seaborn, imported as SNS, pandas. You could do pandas.plot and then matplotlib. That's the 3 that we looked at for visualizations last week. And yeah, pandas, you can do a lot of things with it. Okay, and this is double points. So these ones are a little tougher. Yeah, so we'll go from here. So df.isNA.any axis 1 is going to be rows. And the second one is getting the specific records that have no values. df.isNA, that one gets us like the overview that shows just like columns and then each index and like where in that matrix do you have any null values. It would show like the true and false values. And then df.isNA.any axis 0, it's going to be columns. All right, last one. This is also for double points. Oh, nice. Yeah. So, and this one is tricky because when we convert to, for example, an integer, we're going to do dot as type and then passing int in here. But for date and time, we do pd dot to date time and passing the column. So column equals pd dot to date time. Nice job, everybody. Very cool. Anyone have any questions? Okay. Let's see. We'll turn that one off. And then what do we have after this one? We'll talk about the homework and then we'll take a break and then we'll talk about the final project. So this is scavenger hunt. That's in the shared drive. Copy link. I can also put it in here. If you don't have, no, did I not copy? Let's go back. Oh, okay. My keyboard just stopped working. I don't know why. 1 second. And my camera is having glitches. Don't know what's going on today. Okay. Let's see. Anyways, can everybody? I did put this in Slack. So, and you don't need it right now. This is gonna be for to do on your own. Let me just pull it up. No, scavenger hunt. So this is a notebook that we've been seeing. You can open it either in your local Anaconda or you can open in Anaconda Cloud. If you remember, we could just, what is going on with this one? I really have to figure out what's going on with my, okay, anyways. You can open it in Anaconda Cloud or you can open it in Visual Studio Code. You can open it in local Jupyter Notebooks, whichever you have, whichever you prefer. If anyone has an issue opening it or wants to walk through it, let me know. We could do that. But physically, it's just kind of like questions. You can use Google Stack Overflow ChatGPT, I would highly recommend trying to complete it from some of these maybe like we haven't gone over, but if it's something that we have gone over, try to remember how to do it and then go Google it. You know, the ultimate reason we're here is to learn things. So if you just ask ChatGPT to just copy paste this, you might not learn a whole lot. So if you do Google it, make sure that you fully understand it. And then sometimes there's multiple ways to do things. Like we've seen, you can read a data source, like you can load a data source into Pandas data frame from a local file, a URL, from SQL database. There's different ways to do things. So at least get one of them. If you know there's multiple ways or you find multiple ways, at least get one of them. Or then write all of them. And you can add, so I do have it open up here. So in the Jupyter notebooks, if you want to add another cell, you can click the plus, and that's the same thing in Anaconda Cloud. You can click the plus to create another cell if you wanted to test and make sure that what you wrote works or gives you the proper output. Not all of these are going to give an output, but you can kind of like library for creating visualizations. I think there was like library for working with dates and times. You can like import that library and then maybe do a couple lines of code with it. Any questions on this? I would like to ideally have it completed by end of the week. It's only 20 questions, so it shouldn't take too long to complete. And then I have, I created like a Google form to submit it. If you don't have a Google account or if you have any issues submitting, you can just send it to me on Slack. And let me also share this link. Let me see if this works properly. Any questions on the scavenger hunt homework? And you guys can ping me if there are any questions. But yeah, so this is gonna be, it's in here, scavenger hunt in the shared folder. And deadline is by end of the week. Cool. No questions. Okay, we will take a, let's see, what do we have? We're gonna talk about this and then learn. Yeah, we'll take a 10-minute, so until 7:05. I don't know what's going on. Why doesn't this work? Okay, you can go on break. I need to figure out what's going on with my keyboard because it refuses to work right now. So yeah, be back by 7:05 Central. Okay. Let's talk about the final project. Okay, so we talked about this a little bit last week, but so for the final project, basically what I want you guys to do is to find a data set that you're interested in or just seems like a cool data set to do this project with. Gonna find a data set, and we're gonna discuss about where to find your data set in just a second. And we want it to be like real data, so not just some made up data. Loading data, exploring data, what we've seen throughout the class. We load it with pandas. We clean it up, which is transform it. So data loading, exploration. Want you to understand the data structure, data types, basic descriptive statistics, data cleaning, validation, identify any data quality issues, including missing values, duplicates, inconsistencies, and then apply data validation and cleaning techniques that we've been using. And this one, the data that you choose may or may not have missing values or duplicates, like it might already be cleaned. So I would just like make sure that you check for those things, and then you can like put a comment saying like, oh no, or you can even put like, oh, drop duplicate values, but nothing happens. But yeah, depending what data set you choose, it may or may not have these issues. And then some of these are optional. So like data transformation and feature engineering. So like transfer data to facilitate analysis, normalize it, encode it, aggregation. We haven't really gone over those, so not really expected. If you're interested and if that's something you want to do, feel free to do so. And then like creating new features or variables to enhance the analysis. For example, you could break the age into age groups, saying like, oh, we have young people, whatever, or like you change it to from 18 to 25, 26 to 36, whatever. You can add like calculated columns. That's like an example of that. Exploratory data analysis, identify trends, patterns, relationships with the data, and then optionally use statistical techniques and visualizations with pandas, NumPy, Matplotlib, and Seaborn. We do want some visualizations, but mostly for like the statistics, you don't necessarily need to do that unless it seems it's an interest of you or it would be a really good thing to do with the data. Include some insights and recommendations, derive insights and formulate recommendations based on the EDA. Explain and reasoning behind findings and recommendations. So like pretend that this data set that you chose, you work for the company, you need to, but like we looked at like the sales data. So pretend that you work for a company, they have provided you this data set, and based on your recommendations and findings, they are going to make business decisions. So you just choose what those are, depending on your data set. Create some data visualization and dashboards. So we've done some charts, bar charts, box plots, line charts, whatever seems appropriate for your data. Create. Does not need to be interactive. And a great option is like you can use data that you used, for example, in your Tableau class. You created a dashboard off of it. Now try to do the same thing in Python. If you're able to do it in Tableau and then you're able to do it in Python, that's going to be like really good learning because, it makes sense if you've already done it once. They use libraries Plotly, Bokeh, Dash. I haven't really talked about this, but we've talked about making visualizations with pandas, Seaborn, Matplotlib. So depending on, you can feel free to choose whichever you're the most comfortable with, whichever makes most sense. And then documentation and presentation, document analysis process, findings, recommendations, summarize your findings. We probably won't be presenting this to class unless someone is dying to do so. We can fit that into the agenda, but it's not required by any means. And then probably what it makes the most sense is to provide a Jupyter notebook. That's probably what we all are the most comfortable with since we've been working with the notebooks. So kind of like some of the examples that I walked through, you do your title, like this is where I loaded the data set. And we'll walk through kind of like an example, like a mini project example as well. And then I think we'll do like another sample also next week, or not next week, but on Wednesday. But yeah, like put your sections in there, include any comments, descriptions, whatnot. What's gonna make the most sense for whoever is looking at your project. And this is like great if you want to add it to your portfolio. So like imagine that someone or a future employer is looking at it. So make it pretty and in a way that it's easy to interpret and read and follow. Optionally, you can do like, if you wanted to do just a report or take like screenshots or whatnot, but notebook is definitely recommended. Any questions on this? It's very like, not very restrictive. We've seen examples of this. You have a lot of freedom here. Everything is clear as day. And this one, so we have this week and then we have next week. So this is going to be due end of next week. So that's your final project for the class. Okay, let's talk about a little bit about where to find your data sets. So we did talk about Kaggle a little bit. Very common place to find data sets for analysis, data science, dashboarding. We can see trending data sets. So this is what, like when you come to Kaggle, you want to go to data sets here because they also have like, they have like notebooks already. So that's another thing, like don't just pick a notebook that someone's already done. So like, again, this is for your learning. What to like, you want to know you can do this. So you will have the whole internet, you will have ChatGPT, whatnot. But again, this is for your learning. I don't think anyone's forcing you to be here. So you're going to get out what you're going to put in. Okay. So there's training data sets, universities and colleges, earth and nature, law, transportation, retail shopping, online communities. You can search something very specific. You could do kind of like categories. So I don't know, what are we looking for? Dog breeds. Let's see, what do we find here? Dog breeds, okay. And then this one's gonna like, you're gonna get usability. So this data set is well documented, overview is provided, files are in machine readable format, and code examples are available on kernels. It's 3 KB. There's one CSV file, and here it's gonna, so it tells you a little bit about the data set. Then here's gonna be like the overview of it. So we're gonna see, so we got 8 columns: breed, country of origin, fur color, height, color of eyes, height, tree, yeah, oh, yeah, there you go. Now what else do we have here? Color of eyes, longevity, character traits, common health. And this was kind of going to tell you what is already in here. So it gives you like a little bit of overview what is in the data set. And then you can already also sort it here or search things. This is where you download it. And I think, do you have to be logged in for this? Yeah, so you do have to be logged in to get there, but it's free to join. And then we see, let's see, collaborators, coverage, citation, license, detail view downloads. And then here's like some, so for example, here's like example notebooks of this data set. So like dog breeds analysis. And this is, I think this is a notebook. Yeah. So like importing data and then identifying common problems, whatever. So here's like some examples of what they're doing, but like, don't just do what someone else already did. Like, kind of put your own spin on it and, you know, think your problem solver. What do you want out of the data set? And yeah, here you can see the code, how this was created. And then it also shows like similar data sets here, which I'm not sure how these relate to the dog breeds, but they're there. And then any questions on Kaggle? Okay. And we can look at, we have UCI machine learning repository, popular data sets, new data sets. Here's Iris. This is the data set that we were looking at last week. Very popular one. Heart disease, rice. And these ones, so this is for machine learning, so may or may not fit your project properly, but one way to find, and you can again search them. Looks like auto MPG. Yep. Let's look at this one. I think this is one we were using before. Yeah, that's that. And yeah, I'll make sure to upload this one in the shared folder so you guys have all the links. Then we have data.gov. I want to use government open data. This one might be really interesting. Oh, what do we have here? Here's a great example of what I was talking about earlier. We have last updated Monday, May 6th at 5 GMT. We like to know that. I bet there's, well, I wonder if there's like COVID data in here, for example. Very slow, yeah. COVID-19 outcomes by vaccination status, mental health care, conditions contributing to COVID, school attendance. Yeah, so there might be a lot of very interesting data here to look at. Excuse you. My dog wants to participate. She's very excited about this project you guys are going to be doing. Data world, data.world. Let's see. This one, do they have open data sets or how does this one? I have heard of data.world. I don't think I've used it. Data catalog, governance. This one might not be the best one. Yeah. Resources. Open data community. I think that's what we, yeah, I probably have to sign up for this one. Yep. We have some GitHub. So this is, we've seen in some of the examples, like we just use the URL. So if the data is like hosted in GitHub, oh, 1 second. Oh, can you, if you don't have Google account, give me the best email and I'll add you, I'll share this for if you don't have access yet to the shared folder. Let's see, what do we have here? Small network Stanford. Economics. Yeah, let me look at, let's see, UN Human Development Reports. Oh, this one goes, yeah, I was expecting this one to be, okay. Which ones? Okay. But yeah, here's just public data sets. Agriculture. So yeah, so these are just links to public data sets. And the penguins, oh, that's not the one, but yeah. And then I think you can search on GitHub because like some of the data sets are hosted on GitHub. So like instead of downloading the data set locally, you could just use the link like we've seen in some of the examples. And we have Tidy Tuesday. Solar eclipses. Rolling Stone. But yeah, your best bet is probably Kaggle. And then I think one of the earlier notebooks I also included like Google's, whatever it's called, Google datasets. If you cannot find a dataset, let me know. But there should be plenty in these links. Any questions on the datasets or anything you guys want to look at further in anywhere here? Okay, well, let's do a little mini project walkthrough requested last week. So this one I selected smartphones price dataset from Kaggle. So let's look at this. What do we have here? It's very well documented. This dataset provides a comprehensive collection of information on various smartphones, enabling a detailed analysis of their specifications and pricing. So we have smartphone name, brand, model, RAM, storage, color, free, yes or no if the smartphone is attached to the cell company contract, price, cost of the smartphone. And then here we can also see the kind of a little overview of, we have 8 columns. Compact. So yeah, let's do some analysis on this one. If you'd like to follow along, here's the template, the project walkthrough. Open it up in Jupyter Notebooks, upload it to Anaconda Cloud, open it in Visual Studio Code, whichever is your preferred way to play with notebooks. I'll let anyone who wants to follow along give a few minutes to pull that up, download it. If you don't have access, the link is in the Slack, and if you don't have a Google account, ping me your email and I will add you, and you should get access that way. Okay. Okay. Everyone ready? Does anybody need more time? Is this big enough? Okay. We'll do this more like interactive. So why don't you guys tell me what I need to do here? You can put it in the chat or whatever. So what libraries have we been using? What libraries do you guys think that we will need in order to analyze our data set?
Pandas.
Pandas.
Yeah.
Panda, SPD. Yep. What else?
Probably a data visualization library.
Yep.
Be like Seaborn or Matplot. Is that what it's called? Matplotlib.
Yep. So we have import Seaborn as SNS, import matplotlib as PLT, or this one we get the pipeline, matplot.pyplot. Yep. And then this one we haven't been importing, but let's do NumPy as well in case we want to do something like that. Do NumPy SNP. I think that's pretty good. Start with that one. And then, so I have the data set locally. Let's see, try to walk through the smartphones.csv. I have it in the same folder as my notebook. So how do we load that in? We probably, since we imported pandas, we probably want to put it into a data frame so it's easy to work with. Anybody remember?
So is it PD dot Is it read underscore
Yep.
CSV? Okay.
Yep.
I
Read.
I'm gonna be
CSV.
transparent about it.
I would not like. I had to look this up every single time for the longest time. For some reason, it just like didn't stick. So yeah, so we can put here smartphones.csv, or another way to, if let's just say we wanted this to be in a variable, we could do data path equals smartphones.csv, and then we can put the variable in here if we were to use this somewhere else as well. And then and this one, we want to assign it to a variable. Zenal, you're just joining. We're doing we just started on a little project walkthrough. This is in the shared folder, the template. Okay. If you want to pull that up and follow along with this. We just got started, so you haven't missed out too much. This is the project walkthrough. I think that's the one. Let's see, where was? See, yeah. So in here we have project walkthrough notebook. So opening it up in Jupyter Notebooks, Anaconda Cloud, Visual Studio Code, whatever works the best.
All right, okay. I'm opening it up.
Cool. And then, oh yeah, meant to send this one. Yeah, data set. Here's the link. The data set is also in the shared folder, but here's the link if you want to directly download it from there. But it is also here. Yep. And then, okay, so we have our data path equals smartphones. We want to assign, so this one returns a data frame for us. We want to assign it to a variable. Usually we do like df equals, if we want to be, if you're working on like multiple data sources, you would want to kind of like name them. So like we can call this like smartphones equals PD, and then we'll do smartphones. How do we see how can we look at like the first couple of rows of this data set? Anybody remember?
The head.
Yep, head. And if we just do dot head, it's going to give us the first 5. If we want to do like the first 10, you can input 10 in there. So here we can see our smartphone, name of the smartphone, brand, model, RAM, storage, color, free, then final price. And then let's see. So we'll go. So now we have loaded our data set. We're taking a look at it. Let's do some exploration. What do we want to know? Just to like, when we first start looking, what should we take a look? Maybe we want to see how many rows we have, how many columns. Anybody remember how to do that? Do smartphones dot
len bracket and then parentheses. That's number of rows. No, yeah, that's rows, not columns.
Yeah, that's how you get the length of variable. So okay. With pandas, we have dot shape that gives us the rows and then our columns. Alternatively, we have another method function that will give us a little bit more information that also includes our, like how do we import the second data set? What do you mean by that? So this one you have when you, oh, we don't have a second data set here, but if we had, you would just, like if we were looking at two data sets at the same time, you would just do this same thing, get the different one. And I'm just using a more descriptive like variable name here instead of just doing like df. But you can do df. That's completely fine if you're just working in one, but just to like, you know, good practice using descriptive variable names. But yeah. So just one data set for this example right now. Yeah, so if we wanted to get like a little bit more information about this, like maybe we want to see where do we have, like what columns have null values, what are the like data types, what else, what other functions do we look at that we have it in pandas? Do smartphones dot, we can use info to get all of the information. So we get column name, how many non-nulls we have, and then we got the data types. Alternatively, we can do, if we just look at the data types, we could do smartphones, D types. You see object, floats, final process float is the same thing. So we can see here a little bit, we have some, since we have 1816 rows, we have 1816 non-null values in most of the columns except these two. So it looks like we have some null values in the RAM and then the storage. So we probably want to do something about that. Something that we maybe want to look is maybe get some statistics that can maybe help us with the filling out the non-null values or the null values. Anybody remember what the
So I don't have the full code, but it was like if NA or if null, and like,
yeah, that's how we fill them. But
okay.
Let's look at some maybe stats on like what values do we want to use for filling in the null values. So this is another just like df dot. We can do describe, which gives us some statistics. So for all the numerical value columns, we're gonna get count, mean, standard deviation, minimum, 25th percentile, 50th, 75, and max. So maybe for RAM and storage, we could do like, maybe use the mean or maybe use median to fill in the null values. That could be a good idea. We can see. Let's look at, so we know based on this that there are like close to 500 rows that have null values. So when we're looking at so we already know which columns they are, but we probably don't want to look at every single record that has the null values. If if we even want to look at any of them. But if we did want to look at a couple of them to just see what they're looking like. So to select the records that have null values, we could do smartphones. And smartphones is NA, what Melinda was saying, dot is NA, and any axis equals 1. So this gets us all the records that have null values, but we don't want to look at all of them because we know there's so many of them. So let's just look at a couple of them. There we can see, so RAM is null for all of these. So we have no RAM, looks like for Apple products, maybe. That could be a thing. So why don't we use, I think a good way to fill in the null values, just so we can do some analysis on this, could be maybe looking at the median RAM and the storage for each brand of phones. So instead of doing just like the overall median, we can kind of narrow it down and see like, oh, what does this phone, what do their like RAM and storage usually go for? So we can do, let's see, brand medians equals smartphones. Then similar to in SQL, where you do group by, we're going to do by brand. And then we want to aggregate it by the median. And so we're going to do it both for the RAM and the storage. So we do dot ag. And then here we're going to pass in a dictionary of what columns do we want and what the like aggregation we want to be. So like mean, median, max, whatnot. So we're going to do a dictionary of RAM, and then we're going to get a median. And then for storage, we're going to also do median. And so this is for both columns, RAM and storage. We're going to get the median per brand. So grouping by brand. And I think that will be a little bit more accurate than just doing the total mean or median for the whole data set. So let's look at this one, brand medians. Okay, we have a lot of different brands. So let's just do the brand head. Okay. So we see here, Apple is null, and then BQ is null. So based on that, we don't have any information on the RAM for Apple products or BQ products. So for those, we could do, or actually, let's first fill out, we'll first fill out the records that do have brand, like that we don't have a null here. So we'll fill in those values first, and then we can deal with any remaining null values. So to fill in the brand specific medians, we're going to do a for loop. If you remember from our Kahoot earlier, you start with for, and then we're going to loop through the brand medians, go each one of them. So for brand in brand medians, we're gonna use dot index because that's what the brand is, the index here. And then to fill in, so we're gonna do smartphones dot loc, smartphones brand. So looking at only records that, like looking at records that equal the current brand. So when we're looping through each one of these, we only want to look at the Alcatel brand, Alcatel records in the first round of the loop. So that's what this is doing. And then we want to look at the RAM column. And so this is, so again, we're going to be looking at only the brands. So if the brand equals, then we're going to get the column RAM here. And then we're going to assign this to smartphones LLC brand. Again, brand equals RAM equals brand. RAM. Fill NA. So filling in those null values. We're going to get from brand medians. We're going to get lock brand. So whatever brand we're currently in the loop. And then we want the RAM column. So again, RAM. Something is red here. Are we missing a, let's see, location, brand.
Can you go through that line of text and just tell us again what it's doing?
Yep. So we're going to be looping through this here, our brand medians. The reason we're doing .index is because the brand name is the index. So if you remember previously when we looked at like the index will be just 0, 1, 2, 3, whatnot. So this one, the brand name is actually set as the index. That's we're looping through those.
Okay.
And then from the smartphones, we're going to be looking at the brand, making sure that the column brand equals the current brand. So when we're looping through here, we're going to first look at Alcatel, then we're going to look at Apple, Asus, BQ. So, but we're going to be looping in the smartphones data set.
Mm-hmm.
We only want to look at the rows, the records that currently equal the brand that we're looking at. So when we're our first round, the very first time we're looping through, the brand is going to be Alcatel. So when we're going through the records, we don't care about anything else except the records that brand equals Alcatel. So it's going to go through all of them, but it only looks at the ones where it equals the brand. And we want to look at the RAM column because that's what had null values in.
Okay.
And
sorry, is LOC like locate or?
Yeah, so we looked at earlier, you could do like iLock, which was per, I think that's per the index. No, one is per index and then one is per like just, it's by index, but not index. Like this is by the index name. And then the iLock is like by the numerical order.
Okay.
If that makes, but yeah, so the by dot lock, that's how we get the record.
Okay.
And then let's see, and then so this one is what we're looking for, and then we're gonna, when we come here, we're gonna assign a value to it, which is gonna be using the same thing, like we get the same record here, and then fill the null values
Okay.
with brand medians. From the brand medians, again, we're getting the brand, so that's the index, and then the RAM column, RAM
So
over here.
all of the brands. It gives the medium all of the brands and all of the.
So
all
here,
the values of all of the brands as a median.
A median for each of the brands. So that's what we calculated here. We grouped by the brand. Okay. So we got the median, for example, like for Alcatel, 2.0 is the median for all of the Alcatel.
Okay, because there's more
phones.
devices. There could be several devices of the same brand. Got it. Okay.
Yeah. So like here we see these are all Apple.
Yeah, okay.
So like pretend that these have RAM values. It will get the median of all of these values.
Okay.
And then, yeah. And then, so this one, it's just for this brand of all the devices. These are the medians.
Okay.
And what this null value here tells us is that we actually don't have any values for Apple products for RAM. So all of the Apple devices, the RAM is null. And we'll deal with that after this. But this is how we fill in the null values. Like if we have null values, if we have devices like Alcatel devices that have null value, those are going to get filled in with 2.0.
Okay.
So that's what this is going to do. And then we also want to do the same thing for storage. Let me make sure I'm missing. I think I'm missing one location. So that's that one. No, that's wrong. I don't, yeah, this is extra. And then here, location, brand equals, oh yeah, we're missing an extra one here. Smartphones dot location smartphones. So this one's this, and this one is this. Yep, that looks right. And then we can copy this. And we're going to do the same thing for storage. So all we're going to do is change the RAM to storage over here. Same thing over here. And over here. Storage. So again, smartphones.loc, smartphones brand equals brand. So if it equals brand, get the RAM column, assign it to smartphones.loc. Same thing, smartphones brand equals brand, get the RAM column, fill an A. So we're filling the null values with from brand medians. Oops, from brand medians, get brand, and then get the index like brand, and then the RAM value. And the same thing for storage. So let's run this. No errors, we like that. And then we'll look at, make sure that, well, we know there are going to be some null values, but let's see how many null values we have left. And then is null. And then we're going to get some for these. Okay. So for storage, we were able to fill in all the null values. For RAM, we still have 296 values that are missing. So for that one, and that's because like how we were looking at here earlier, Apple, we don't have any information for that brand. So for these ones, we can do, let's just do the total, like the overall median for the rest of the values. So we can do RAM median equals smartphones RAM. Anybody remember how to get median? It's just median, which is nice. That's a pandas feature. Or you could do .mean or whatever else we were looking at. And then we're gonna fill in smartphones phones, RAM, do the fill NA, RAM median, and then who remembers, how do we, what's the argument that decides whether or not we're doing it, whether or not we're modifying the original data frame? We had an additional argument in here. So if we want to modify the original data set or the data frame, we're going to do in place equals true. If we didn't have this, it will just output like what it would look like if we did do it to it. But doing in place, it's going to modify the original. Alternatively, we could do like smartphones RAM equals smartphones RAM, and then not need this. And it would just kind of like assign it with it. So true. And then let's look at how many, we can look at this again, just the RAM, make sure that they were all filled. So 0. So all of them are filled. Then let's make sure we don't have any duplicate values in here. So duplicate rows equals smartphones dot duplicate it. Then we can just look at the sum of it. Let's see, what do we get with this? 0. So that's good. Okay, and then and we can look at after, since we filled this one in, we can look at this same thing again. And we wouldn't, let's see, we had like 10. And now we see that there's no values anymore. So everything got filled in, which we already checked here with calculating it. But we can see now that if we were to calculate the median again per brand, we'll get it, which this is not the same for these ones, EQ and whatnot. Any questions on this? Okay. And then, so let me show an example on like the feature engineering, what I was talking about earlier. So if we wanted to like categorize per age group, or let's just say we're looking at credit scores and we want to categorize that all above 800 is excellent credit score, and then between 600 and 800 it's a good credit score and whatnot. So we want to add another column that's going to categorize it. So let's do, so what do we have here? The smartphone, brand, model, RAM. So we could do something with the RAM or the storage or with the price. So why don't we do with the price, we're going to categorize it on like what like price bucket it lands into, like whether it's like a budget phone or like a luxury phone or just like a, regular mid-range. So we're going to do, and this one we haven't looked at before, so you might not know this. So we're going to do our bins. So this is what decides kind of like the cutoffs for what what bucket things are going to go to. So we're going to go from 0 to 200, 200 to 500, 500,000, and then we'll do infinity, like 1,000 and above. So this one, like with the bins, you kind of need you need the bottom limit, and then you need the upper limit. And so here's our NumPy. We can access infinity. So that just means like above 1,000. And then we're going to do the labels, surprise labels. We're going to do, if it's between 0 and 200, it's going to be a budget. Then between 2 to 500, we'll do mid-range. Then premium, and then we'll do luxury. And so we have an array or list of integers, and here we have a list of strings. And then we're going to add a new column to our smartphones. So we're going to do smartphones price category. This is going to be the name of the new column. We don't have this here yet. We only have these ones. This is how you add a new column, smartphones, and you just name it. It's kind of like you assume it's already there, but this is how you create it. And we're going to do PD cut smartphones using final price. So that's our price column. Let me pull this one up here real quick so we can see it better. Yeah, final price. And then our cut method is going to take in the column that we're looking at, and then bins is going to be equal in price bins, and the labels are going to be price labels. So what the dot cut does, so we're creating a new column, price category. We're going to be looking at the final price column, so over here, and determining what the label should be based on the bins. So again, if it's between 0 and 200, it's going to label that record as a budget. And if it's between 200 and 500, it's going to be mid-range. So like this first one, this second one, these are going to be mid-range. This one's going to be budget, mid-range, and this one's going to be premium. So run that. So pandas, pd.cut, smartphones passing the column, bins equals price bins, labels equals price labels. And then let's take a look. Smartphones.head. So now we have category here. Mid-range, budget, mid-range, and premium. Any questions on this? So this is like for your project. I think the feature engineering is like that was marked as an optional, but here's an example of like what you want it to. So then we can, instead of looking at every price, we can kind of look at them by category.
I got an error on mine that said the name NP is not defined. Did I maybe just miss earlier where we defined it?
So NP is NumPy. So import NumPy as NP at the very top.
Oh, I must not have imported that. Okay. Yep. Okay. Got it.
And you don't have to import them at the top. That's just like best practice. You could import them like right down here, but it really also doesn't matter because you can go and add it here and then just run this and then go back down. Like you don't have to rerun all the cells or kernels. Did that work after you imported it?
Oh, I have to type in smartphones had.
Yeah, to look at it.
I think so. Yes, it looks like it did.
Nice. Okay. Let's do a 10-minute break right now, and then we'll get into data visualization. Any other questions before we go? Everybody good? Okay, we'll do 10 minutes, so be back by 8:15.
I shared my email in the Slack, if that's all right, if to give access.
Yeah, I think I added.
Because I have an email, but sometimes I use my school mail when I signed up for the classes because that's how.
I added you. Did you get
We're in a tornado warning down here, so I might have to
Oh,
leave my the sirens are going off, so I might get
goodness.
back on my phone and go to the basement, of which my setup isn't here, but probably
Okay.
yeah. I will can you hear the sirens going off in the background?
I did hear that.
Yeah, I'm down in Bellevue. I don't know
Yeah,
where you're at if but I better head downstairs and I'll get back on Slack on my phone then. But yeah, if you could, I'll try to check the drive too when I get back up here.
Yeah, I did add your email on there. If it's still not working, let me know and I'll take a look at it. But
Okay, that sounds
get to
good.
safety.
Yes, thank you. All right, bye.
Bye. Okay, we will take a break. Hopefully, no one else has tornado warning. That's so scary.
I'm
Like
looking at
everyone,
the path.
they do like you can see like a forecast for where they estimate the tornado to go. I'm like, tornado so foreign to me. Like I have never been anywhere near them. Like hurricanes, it's kind of like, oh yeah, it's coming one day. But tornadoes, like those freak me out.
Yeah, I don't know.
Okay, we'll do till 8:20. If anyone else has a tornado warning, let me know. Just ping me in the chat or wherever. Hopefully everybody stays safe. But yeah, we'll do a about 10 minutes. So be back by 8:20 Central. Okay. Let's get into some data visualization for our little project. So I wanted to share one way to do like kind of like dashboard looking visualizations, we looked at the mosaic way to do it. But we can also do that with the matplotlib. So you guys remember we did fig and then axes, and then we do plt subplots. And then here we can define how many rows and columns we want on our like dashboard or like in the figure. So instead of and then we do the figure size as well. So n rows, let's do 2. We do n columns equals 2. So we'll do 2 and 2, and then our figure size is going to be 14 by 10. And then this one's not necessary, but it just makes it a little more readable in my opinion. We do tight layout and then add a little bit of padding. 6. And then, so let's do a box plot of the final price, or the price, and then the price category. So that's going to be using Seaborn. So we're going to do SNS dot box plot. Then our x equals axis 0, 0. So this means that we're putting it in the first corner, like corner. 0 row and 0 column. So for our axis, we did 2 rows and 2 columns. So we have a four charts. And so this is going to be the location of it. Then we're going to do x equals price category, and y equals final price. And then our data going to be smartphones. And then we're going to do a setting the title for this. So axis 0, 0. And this one could be, we could do this before even filling in with the box plot. So axis 0, 0, set title, final price distribution by price category. So we're going to do a nice box plot in the first corner, on the first location. And then let's do maybe a bar chart of like count of the each category. So in Seaborn, a bar chart for count plot, we're going to do x equals axis, and then row 0, column 1. So the second location on our four grid, 2 by 2 grid. X is going to be price category, then and data equals smartphones, and then yeah, and so this one's gonna, we just get the count of each category, and then again we'll set the title. We just copy this one, axis 1, set the title. We're gonna do number of smartphones in each price category. Then let's do we'll do a scatter plot of the RAM and final price. So again, SNS.scatterplot x-axis. We're going to be doing 1, 0, row 1. Oh no, sorry. Yeah, row 1, column 0. And then X is going to be RAM. Y is going to be final price. Data equals smartphones. And then we're just going to set the title again. And we'll change here 1, 0. And this one we're going to call to RAM versus final price. We could have totally just like renamed this just price instead of final price. Instead of, yeah, just to make it a little bit more cleaner and, you know, easier. You don't have to keep typing final price. You can just do price. And then let's do the same thing for the storage question.
Can you remind me what after the Y equals final price, what the M is for?
Oh, that's a mistake. That doesn't belong there.
Okay.
Yeah. Nope. That was supposed to be a comma. Yep. So we're just setting the X, whatever column we want for X and whatever column we want for Y, and then the data source of that. Axis, X, Y, and data. Yep. That's all that is there. No wonky M's. That would have given us an error. And then, yeah, we'll do the same thing for storage. And we're going to change this one to 1, 1. So it's our last spot. We're going to do storage, final price, storage, then here 1, 1. So our left corner, upper left corner, we're going to have our box plot of the price distribution by price category. Then we got the next one over. So right upper corner, number of smartphones. So this is the count plot is same as a bar chart. Scatter plot in our lower left, RAM versus final price, and then our lower right, we're going to have storage by final price. So let's run this. Okay, we get some pretty things here. So final price distribution. Now I'm going to spell that. Distribution. Yep. Final price distribution. So we have, and this one, since we've set the range for these, it makes sense where we are. So like here, it goes up to, budget goes up to 200, mid-range goes from 200 to 500, but majority is probably around like 350, I would say. And then premium, again, from 500 to 1,000. Midpoint, maybe around 750. And then luxury is everything above 1,000. And then there's a couple outliers here that are like way above, like, or those are probably like 200 to 2,300 or something like that. But majority of the above 1,000 are between 1,000 and 1,500. So the lower diamonds, those are the outliers. And this is the full range. And then this is the mean, and then the distribution around it. The number of smartphones in each price category. So we got about 450 budget smartphones. Majority is mid-range, so over 700 mid-range phones. Maybe like 730 or something. Premium, similar to budget, and the luxury is around 200. Then we can see here, so RAM is at the bottom, and then our price. And this one has just kind of like, not really correlation. Because we're seeing, I mean here, cheap ones here, but then here we see RAM of 12, anywhere from a couple hundred to a couple thousand. And then for the storage, this was very interesting. We have one here that's below 500, but rest are above here. So that one kind of makes sense. And then same thing with the cheaper phones, very little storage. So that's interesting. So this is a very nice little dashboard we have here. And then let's do a couple other ones. We're gonna do same thing for, well, not same thing, but fig axis equals PLT. Subplots. We're gonna do 3 rows, and rows equals 3, and calls equals 1. So we're just gonna do 1 column and then 3 rows. Fig size to 12 by 18. And then we'll do the tile layout. And we'll do a little more padding here. And then let's do a price category breakdown with brand information. So like we'll look at each brand and like how many, like which category phones do they offer, and like how many they have. So we're gonna get, first we need to get our, and we'll only want to look, because we had earlier, I think, let me do a second here. Let's see, smartphones brand. And then unique. Okay, and then let's do count. Nope, not count. Some. Nope, not some. This one. No, we can do length here. So we have 37 unique brands in our data set. So let's just look at the top 10. So we're going to do top brands. Smartphones, and then brand, do value counts, and then we can do n largest and 10. So this is how we get top 10, top brands. Smartphones, get the brand column, get the counts, and then we're gonna get the top 10 that have the most. And then we'll do the index. And then we will do a little filter data for smartphones, and then smartphones brand. We can do is in top brands, and that's a way to filter the brands, or like the records is in top brands. Let's do a bar chart. We'll do a vertical one. Oh no, horizontal one. And again, SNS. So count plot x equals axis. We're going to do 0. And this one we can do 0, 0, but since we have only one column, we don't have to just about that. So 0, y equals brand. And then we're going to do by the price category. So the colors by price category. So hue equals price, price category. And then feed-in data equals smartphones. Oh no, not smartphones. We want the filtered data. So we only want the records that are in the top 10. And then we're going to set the title, axis 0, set title, number of smartphones by brand and price category. And then we're going to set, we'll put the legend in there as well. 0 legend is the price category. And then let's do another one. Well, no, yeah, we can do, for the top, let's look at this one by the brand. It's easier to, you don't want to really, you could look at it for all of them, but since there's 37 different brands, but we'll look at it for the top 10. So we'll do the same scatter plot. So we can basically copy this one here. And let's see. Scatter plot. We're going to do axis 1. And then RAM, final price. We're going to add hue by price, no, not price category, by brand. Brand. And then we have our data is going to be the filtered data. Oops. Just this one, filtered data. And then let's do the set title by brand, and then do the legend. And this one also we need to change axis 0, axis 1. Axis 1 legend. And we title equals brand. Then location is going to be upper left. And then we can anchor it as well, which is, yeah, dbox to anchor. And that's just like for the location. I don't think, or we'll look at it without it first. We'll see what it looks like without it. But we'll do one more. We'll do price distribution across the top 10. Yeah, we had the filtered data. So we'll do SNS, box plot, x equals axis, 2, x equals final price, y equals brand, data equals filtered data, not filtered date, filtered data. And then we want to do set the title, axis 2, set title, price distribution across different brands. And let's see what we get with this one. Yeah, we have an extra fig size. What's wrong with this one? Position argument for subplots in rows and columns. Fig size. Oh, fig size equals. Yep. Okay, so what do we have here? So we can see, honestly, the most surprising to me is that Apple has like budget phones because I thought all of them are like over $800. So I don't know if this, apparently the data is real, but it might be taking, I wonder if it takes into like watches and stuff. Or maybe they do have cheaper phones that I just don't know about. But yeah, so we can see Xiaomi, lots of mid-range. There's a couple that only have budget and mid-range. But yeah, Apple has the most luxury expensive, and then Apple and Samsung, that makes the most sense. Makes sense, yeah. And then we have, okay. Yeah, this one, we still have like so many devices here. So maybe we could, let's look at this by just 5 largest. So we have Realme, Samsung, Xiaomi, Apple, and Oppo. And then here we can see, yeah, we have Xiaomi, Samsung mostly down here. Then we start to get Apple here. Yeah. And then here's price distribution per, lots of outliers here. That's interesting. Same thing for Samsung. Apple has the like largest price difference or like variety. That's very interesting. Didn't really see that one coming. Let me change this back to 10 to look at the last one. Very interesting. Yeah, Samsung and Apple the most. And then we can also, so let's, where's this one's over here? And what did I want to do with this one? The BB box? That one, like location, upper. This is just like formatting to anchor. And we're gonna do top, we're gonna do anchor 1, 1. And how does this one change? So this is how, if you want to put the legend outside of your chart. So if we had like data up here, we wouldn't want to cover it. So we can do B box to anchor, and then we do 1, 1. And that's how you can get it outside of the chart. I'm not fully sure about which ones. Okay, interesting. That's something to play around where to like put it. But yeah, 1, 1 gets it to the side. I don't know what 1, 0. Okay. I'm not sure what these exactly, what the location means here. We can read about that. And then we can also set, in Seaborn, we can do palette for the color. So palette, we have Viridis. And then for this one, we can do palette. We'll do set 2. These are just different kinds. So now we have changed the colors here and change the colors here. I think we can do that one for, let's see, palette, set 2. Yeah. So here's some examples on for your project and ways to kind of, you know, what you could do is like do your notebook. You know, you do your whole thing, and then we could, or you could export these as pictures and like put them on a Word document or Google Doc, and then put some like insights or recommendations and like do like a little report, or you can just like include them in here. So adding a new kernel. So changing this to Markdown, we could be like, here are my insights about these charts. And then we have a text box here. We can add a insights and recommendations. And this is called Markdown. So that's a language. So you can do like, look at Markdown syntax. Markdown cheat sheet. So headings, zoom in on this one. Bolding text, italicizing, doing a block quote, ordered list, unordered list, entering code. And then if you want to do, I don't think this will be necessary, but to do like multiple lines of code, you would do 3. And then you can also set it to Python. It's like print hello world. And then use these. And then that's how it adds it in here. I think if we don't put the Python in here, it just does, like it's code, but it won't do the colors. But yeah, that's how you could do it. Just like add your titles and add your insights in a notebook. Any questions? Easy peasy lemon squeezy. So for end of the week, complete the scavenger hunt. This is in the shared folder, scavenger hunt. Upload it, either open it in Jupyter Notebooks, Anaconda Cloud, Visual Studio Code. Personally prefer Jupyter Notebooks, but if you don't want to have the local distribution, just do Anaconda Cloud. And yeah, complete here. Not everything is going to be, we talked about this earlier, not everything might be like a bunch of code, whatever. It might be just an answer. But for example, where it's looking for the dates and times, so like import the library and then like maybe do a couple lines of code with it. Learn something about it. You'll probably use it later on. Some of these we have not necessarily covered. So just, you can Google, ChatGPT, whatever, Stack Overflow. So yeah, this is due end of the week. And then the project, where is my, the final project will be due at the end of the class. So we have this week and then we have next week. So end of next week is your final project is going to be due. If you have any issues with installing Anaconda, installing Jupyter Notebooks, opening up these notebooks, you can't find data sets, you should be able to find data sets, but just in case. Yeah, just ping me in Slack, whatever. I'm here for you guys. Any questions on anything at all? And I'll also put what we did here today. I'll put that in the folder as well, so you guys can see, in case you didn't catch on some code here. Sure, we went through everything. Yep. That's it for today. If nobody has any questions, I hope everybody is staying safe. I looked at the radar. It looks a little crazy up there. So stay safe. Python can wait. It's not going anywhere.
Did you
Okay.
say that the scavenger hunt is due Wednesday? Sorry, or the end of this week?
End of this week.
Okay.
So like whenever you can just let me. I don't think I'll upload this thing, but then let me also put this link in here. Put a let's see here somewhere. Scavenger hunt. Due by end of the week.
And then this like this quiz notebook was also in here. Is that due? Sorry if I missed when you said.
No, that one. We'll probably go that over next class. Yeah, I had it there in case we had time to get to it. But we'll do it. We'll do it on Wednesday. So don't worry about that one.
Okay.
Just more learning in a different way.
Okay.
Okay, and then I put finish order. Let's see, scavenger hunt. Okay. Any other questions? Any other questions you have at any time of the week, just ping me. I'll look at Slack occasionally. If no more questions, we're done for today.
Okay.
Perfect.
Okay.
I will see everybody on Wednesday.
Thanks. Have a good night.
Thank you, everybody.